Hello everyone. So today we're going to be doing 2x2 and 3x3 Hill Ciphers for Codebusters and Science Olympiad. Um, so first, to be able to understand Hill Ciphers, we're going to have to know what mods are. So this is just some simple notation that you're going to have to use to be able to like complete these ciphers. So basically, mod is like the remainder of like when you divide two numbers together, the remainder of that. So for example, if I have a number, let's say, um, keep it simple, 11, right? 11 mod 2. So this is saying is the remainder when you divide 11 by 2. That's equal to 1. So 11 mod 2 is equal to 1 because 2 goes 2 times 5 is equal to 10, and then the remainder is 1. So another example would be, well, in first Hill Ciphers, because there's 26 characters in the alphabet, each one of them, 26 letters in the alphabet, each one of them has a unique number associated with it. So in order to get larger numbers down to one between 0 and 25, we're going to have to do mod 26 a lot in Hill Ciphers. So it's good if you guys can memorize the multiples of 26 up to like 416. I'm gonna write them down later when we're solving the cipher, so we can easily refer to them. But you're gonna have a calculator available during the test, so you can use that. So if I say 85 mod 26, 26 times 3 is equal to 78. So 85 minus 78 is equal to 7. So that's going to be the answer to this. And we're just going to be using that to basically get the numbers down to ones that we can correlate with the alphabet. And it has to be between 0 and 25. Okay. Along with mods, we're going to need to have some basic knowledge of matrices and multiplying them together. And in addition to multiplying, which I'll show you guys later, we're going to have to know how to find the inverse of only 2x2 matrices. So the reason why we do that is to be able to, like, that's a process that we have to use to be able to decrypt the message by finding the inverse matrix of this 2x2 matrix. We don't have to do that for 3x3 because it's more complicated, and the test will give it to you, so you won't have to do that, and you can just start with the decrypting when you have it 3x3. But for 2x2, since it's simpler, you're going to have to calculate the inverse, and they won't give it to you. So the first step is to find the determinant of this 2x2 matrix here to solve the cipher. So the way you do that is, if you have a matrix A and then A, B, C, D, the determinant of A is equal to AD minus BC. So it's these two numbers minus these two numbers. So that's going to give you a numerical value, and then you're going to have to do mod 26 to get the number between 0 and 25. So for this example, the determinant would be 17 times 5 minus 0, which is 85, and then mod 26 is 7. So that's going to be your determinant here. And then you're going to need to know the multiplicative inverse for this. So it sounds complicated, but basically it's like, it's when you have this. So basically you find a number multiplied by 7. So 7 times some number. The mod 26 of this gives you 1, basically. So that's when you're dealing with mods and inverses, this is the formula. So like, if I got like, for example, if I got like 5 here for the mod, like after I did for the determinant, then it would be 5 times some number. Mod 26 is equal to 1. It's always equal to 1 for multiplicative inverses for mods. So on your Codebusters reference sheet, it's going to give you the multiplicative inverses in this table over here. So the multiplicative inverse of 7 is 15. So n would be 15 in this case. And this is the number that you're going to be using from now on. So we also have to find another matrix called the adjoint matrix. So the way we do that for 2x2 is, back to this general formula, the adjoint matrix of this would be equal to D negative B negative C A. So we end up flipping these two, D and A, and then we make B and C negative. This is negative, and then these two are flipped for the adjoint matrix. So the adjoint matrix of fear, this one over here, would be 17, negative 4, 0 still, and then 5. And then we're going to have to multiply this number over here that we got to this matrix. So the way we do that is you just multiply 15 to 17, negative 4, 0, and 5, and you'll still be left with the 2 by 2 matrix in the end. So 15 times 17 is 255. 15 times negative 4 is negative 60, and 0, and then 75. And then we're going to have to do mod 26 here again to get these numbers between 0 and 25. So this is when you can... So first I'll deal with the negative 60. So for negative 60, for any negative numbers, you just keep adding 26 till it becomes a positive number. Any multiple of 26 till it becomes a positive number. So 78 plus negative 60 would give you 18, and that's between 0 and 25. So that would be this number over here. 0 stays the same. 255. So 26 times 10 is 260. So you can just subtract that, and even though it gives you a negative number, you can add 26 after that. So it would give you negative 4, but negative 4 plus 26 is equal to it would give you negative 5, and negative 5 plus 26 is equal to 21. And then 75, you can do similar things. So like 75 minus 52 or 75 minus 78 plus 26 gives you the same thing. It's 23. So now with this matrix, we're going to be able, this is the inverse matrix that we were trying to solve for. And then with this matrix, we're going to be able to decrypt this cipher. So the next step to be able to do this is to find, you have to find each of the numbers that correlate with this letter. So it gives it to you in a table in the reference sheet, and I would highly recommend memorizing this because you're going to need them often. And once you get into the hang of it, you're going to start remembering certain numbers like A0, Z25, etc., and some other numbers in between. But you're going to have to convert this all these letters into this corresponding numbers, and it makes it much easier and faster to do at the competition if you memorize this table. So I'm going to do that right now real quick. G6. D3. And 7. Okay, so once we do this, we can finally start the math. So with the 2 by 2 matrix, you can only decrypt 2 letters at a time. So we're going to group these letters into groups of 2. And then we can finally start the math. So we're going to take our inverse matrix, 21, 18, 0, and 23. And we're going to take our first group of numbers, first pair of numbers in this case, 19, and 15. And then we're going to multiply it like this. So when we're doing multiplication like this, right, your answer will be a 2 by 2 matrix. Sorry, it will be a 1 by 2 matrix, which like similar to this matrix over here. Sorry, 2 by 1. So you would multiply this number with this number and then add it to this number times this number. So that would be this one to this one and this one to this one. So 21 times 19 plus 18 times 15. And then that's going to give you 669. But then we have to do mod 26 to get that between 0 and 25. So that would give you 19 here. And then for the second number, we're going to be doing 19 times 0 and then 15 times 23. So it's just a pattern that you're going to keep doing for each of these pairs here. So 19 times 0 is 0, and then 23 times 15 is 345, and then we do mod 26, and then we get it to 7. So our first letter would be the one that goes with 19, and our second one would be 7. So 19 goes with T, and then 7 is H, and that's like according to our table up here. So we're gonna do the same thing again. When you're at the competition, you don't have to show your work, so it's probably best to just write the inverse matrix, pair your numbers, and just like go through it mentally and quickly to find the letters that, like the plain text letters. So the next pair is going to be 24 and 4. So that would be 21 times 24 plus 18 times 4 mod 26, and it would be 4, and then 24 times 0. So whenever you have a 0, you can ignore that number for that specific calculation. 23 times 4, 92, minus 78, that would be 14. So 4 would be E according to the table, and then 14 would be O. So another trick I would say is, always do the first letter of each one. So like do alternate. So do the T here and then find the E when you're plugging it in, so that you can, first of all, you'd be multiplying by the same number. So you'd always be doing the first number times 21 and the second number times 18. And it's just faster to keep repeating the same calculation. Of course you have different numbers here, but it's definitely better than doing 21, 18, and then 0, 23, and then switching the numbers and repeating it like that. So 1, it's faster to do, and 2, you can also guess certain letters in here if you have every other letter. So you're not like obligated to do every letter in a row, because if you can guess like reasonably, you can always check your answer too. But if you can guess, then you can solve the cipher faster. So now I'm going to start doing alternates, and I'm actually going to do alternate with this calculation with 0 and 23. The reason why is because we can ignore our first number in this case, because it's 0, right? So in this case, for this pair, when I do the calculation, I would just do 23 times 5 mod 26, and that would give me 11, and 11 is L, so this would be L over here. And now, because the first number doesn't matter, right? It could be 6, 5, 11, 5, 13, 5, but I always get L over here because the first number is being multiplied by 0. So now I can look ahead and just see if there's any other numbers that have 5 in the second spot. So it doesn't seem like there are any. So we can continue on with that. So now I would repeat this with 23 times 11, and then you'd get t, you get 17 or 19. And then for this one, so now I'm going to like sort of speed it up because we get the gist of it. This one would be I. And then like after we do each one of these, we can check and see if we have it from before. So like for example, here, L or 11 shows up again in the same spot. And because the first number doesn't matter, we know this has to be a T. And this one would be G. And now I'm just going to sort of fill these in really quickly so we can move on to the next part, because all this is just repetitive calculations. Okay, so now we can, since we have every other one, right? It's not like very clear what the words are, but now we can go back to the first column and do the slightly longer one. So once you do the first letter for this, you're gonna find that it's 13, which is N. And now like the like O and L, that sort of looks like Y. So I'm gonna put Y in here. If it doesn't work out, then we can always check it and make sure and see if it's a different letter. But then that would like speed up the process because we can do less math and just like guess the letters. And this one, if you do it, it'd be H. So this one would be probably thing. So the only thing. This one is W once you do the calculation. So the only thing we. This one's H. So this one could be T, like the only thing we hate, only thing we have, maybe some other options too. But so this is when I would like do the calculation, because there could be multiple things, multiple letters could work in this case. And when you do it, you get V. The only thing we have, 2. And this one's an F. And now this quote might look familiar to you. This one's an A. So once we've sort of done most of it, we got like the only thing we have to fear. And then if you know the quote by a certain US president, it's the only thing we have to fear is fear itself. So this is just an example of when you can just like sort of guess, and then if you're not sure, you can always like check some of the letters that you guess, and if they line up, then you're probably good to go and it's safe to make the assumption. So yeah, that's going to be the answer to this cipher, this 2x2 Hill cipher. So now we're going to be decrypting the 3x3 Hill cipher. So this is mostly similar to the 2x2, except you're going to have to group these into 3, and then you can technically decrypt 3 letters at a time with one matrix. So the first step, since we already have the inverse matrix, is to assign the numbers for each of these letters. So I'm going to do that real quick. And you can also follow along with the table if you haven't memorized them yet, but I would strongly suggest doing so. Okay. So now we can group these into 3, and we can begin decrypting. So we already have the inverse matrix, which is 21, 21, 13, 19, 4, 21, 1, 2, 5, 22. And then we can take our first group of 3, which is 0, 18, and 3. And then now because we're starting off with a 0, right? We can, for this first group, we can essentially ignore the first column because they're all gonna be they're all gonna be multiplied with 0, so it's not gonna change our final value. So first we could do 18 times 13. So the order would be this number times this number, these two, and then these two. So it's very similar to the 2 by 2, except you're adding another multiplication calculation. So 18 times 13 plus 9 times 3 times 19, which is 291, and then mod 26, so we'd get 5. And then we can try with the second letter too, which would be 21 times 18 plus 3, and that would be 17. And then for the last one, we could do 18 times 5 plus 22 times 3, which is 66. And then that would give you a remainder of 0. So now we can take those letters again, and then similar to 2 by 2, we can put them in here. So 5 is F, 17 is R, and 0 is A. And similar to how we can do alternate letters in 2 by 2, we should probably do that here as well, because we can sort of guess the letters too. Also, typically, the keyword will have something to do with your cipher, your plain text. So in the case before with fear, that was in the quote itself. In this case, this sort of looks like presidents, and we just had a quote from President Franklin D. Roosevelt. So this is probably going to be his name. So just to check and make sure it's not something else, we can sort of do the alternate. So here we have, I'm just gonna do this quickly so we can just like get the cipher, because the main idea is just getting it. It's just a ton of like steps in repetition to be able to do that. This is N, this one is O, V, and T. Also, just to illustrate a point, for this last cipher, for this last group of 3, 16, 9, and 0, this last letter is actually Z. So typically, like once you do the calculations and everything, you're gonna get that this last letter is gonna be Z. With you're gonna get like the 20, this pair over here with 25. So typically, if the plain text isn't long enough to take up the groups of 3 or groups of 2, this could happen in 2 by 2 cipher. Typically, they're going to end off the cipher with enough Z's to make it make the total amount of letters in the plain text a multiple of 3. So don't be like thrown off if you see a Z at the end. And it's often a good idea to figure out how many Z's there are at the end, so you don't like guess too many letters, and then even though it makes sense, it might be a Z. So it's definitely better to see how many Z's you have. So in this case, we have T and then Z, so we only have one Z, and we can definitely like guess that this is probably his name, Roosevelt. So just to illustrate a point here, Franklin D. Roosevelt's name is also spelled with the D sometimes in here. In this case, just based off of the FRA, we wouldn't know if there's a D or not, right? So if we just guessed his entire name, we would end up pushing everything from here onward one letter to the right, putting a D in, and this Z would end up being like not there, and that's wrong because we didn't check to make sure that every letter match. So like if we just like put a D in there and then shifted everything to the right, the entire basically half of the cipher would be wrong. So it's important to find the Z's at the end and also check in between to make sure like some letters match up so that you know you're on the right track. And so that's about it for the 2x2 and 3x3 Hill ciphers. I hope this video helped and with your Codebusters and Science Olympiad journey. Thanks for watching.